Hi everyone. So today's lesson is going to be a derivative of inverse function. This is the last thing that we have to do in order for for us to complete everything about the derivatives themselves. Before we go into the last push of this year, and this is something that I have been talking to you about from the beginning of this year, and that is for us to be able to draw the graph of any function given. So basically, derivative of inverse function means we're going to find what is going to be the derivative of inverse function. Now, in order for us to be able to talk about the derivative of inverse function, we have to go through and remember what we talked about inverse function itself. So let's go through the example to remember what we have been talking about earlier. Example 1, just so we have a number. So example 1, let's say you are given a function where f of x equals to logarithm base 2 of x. Now, we know already that the logarithmic function, its inverse, should be exponential function. Now, let's go just through the method of getting the inverse function. Simplest way possible. So the idea is, instead of f of x, let's write down y equals to logarithm base 2 of x, and we want to express the x using dy. At the moment, y is expressed as something with the x. So how do we do this? Well, we have the snail method, where 2 to the power of y equals the x, or x equals to 2 to the power of y. Simple as that. We don't have to complicate things at the beginning. So what this means for us, that the inverse function of function f is f to the power of minus 1 of x equals to 2 to the power of x. Now this is the idea, okay? Now we have everything that we need, and now we can say that the inverse function of logarithmic is exponential, and we could apply the same thing going back. Now if we defined that the original function is, for example, exponential and written down as g of x, then the logarithmic function would be then g to the power of minus 1 of x. Okay, that's the idea. So we can always go back, and both these functions are inverse to one another. Okay, so they're to one another inverse. Now, there is something that I want to talk about it using this specific thing, and that I've already told you before when we were talking about the inverse function themselves. And this is something that you guys actually came up with. This is not something that I told you, but you asked me, a couple of you asked me when we were solving tasks with inverse functions, was, what is going on with the composite function? Or what is going on between f to the power of minus 1 of x? Now let's find out in this here example exactly what's going on. So f to the power of minus 1 of x is actually f of f to the power of minus 1 of x, which then is f of f to the power of minus 1 is actually 2 to the power of x. So what does this mean for us? We have to, instead of x, use 2 to the power of x. And this is logarithm base 2 of 2 to the power of x. Now we are not done with this here form, because we can simplify it. Why we can simplify it? Because we have index inside of the logarithm, there is a certain index law which tells us that if you have index inside of the logarithm, the exponent itself, you can then put it or move it, however you want to say it, in front of the logarithm, which means that this is actually equal to x times logarithm base 2 of 2. And one last thing, and this is also important for the state exam, aka Državna matura, where logarithm of a base logarithm base of the certain base of a number, the same number is actually equal to 1. If you think I'm not correct, you can try it with any base positive, of course, the positive n different than 1, and try it on the calculator, and you're going to say, get it that it is equal to 1. What this means in the end, that f to the power of minus 1 of x is equal to x. Or we can rewrite it down as using the f to the power of minus 1 of x is equal to x. And this here in the end thing will be equal to x for any two inverse functions. So composite or function of two inverse function is always going to be equal to x. Now let me just add something to this. So here's going to be h of x, which means that h of x equals to x. And there is a connection between the composite of inverse functions and inverse functions themselves, specifically looking at the graph of the functions. What this means for us is, let's draw a coordinate system. X, y axis, don't forget about them, especially for state exam, okay, if they are not written down already. And let's draw the logarithmic function, exponential function, and the composite. Now, the logarithmic function should look something like this. So this is the logarithmic function, okay, this is the sketch. Let's draw the exponential function. This should be the exponential function. And in the end, the composite. Composite is equal basically the h of x equals to x, which means this is the linear function, which means that the graph is a line, not any line, but line that goes through the center of coordinate system and looks something like this. Now, if you would draw all of this being as neat as possible, this means that you actually use the table, filled in the table for the logarithm, for the exponential, and for the x, you would see then immediately, now I've used the sketch here, but I've used it so that you can see it, is that the x or the composite function, its graph, is like a mirror. Like a mirror considering these two graphs. And this is the connection between everything together. So if this is f, if this is f to the power of minus 1, this is f to the power of minus 1. And this is connection between them all. Basically, the composite function of two inverse function is their symmetry. So this is why, and this is something that we already learned in the second grade, guys. This is something that we did in the second grade, and this is not the first time that you draw this line here. This is not the first time, everybody. You have done it before. Some of you may have forgotten about it, and this is okay, perfectly. You have so many things in your hand already. That this is something that we have done sometime in the past, but now I'm giving you this again so you can remember about it if you can. So the graphs of this function are symmetrical considering their composite function or graph of the composite function. And this will be for any two inverse functions, okay? And this is the beauty about the inverse functions, and this is the conclusion of it all. This is the conclusion of everything that we've done so far, considering the inverse functions, the composite functions, and now we can finally go into the derivative of the inverse function. Now, what I'm going to do in all of this, I'm going to change things a little bit so I can be more similar to the textbook, even though I'm not going to use the textbook itself. In this case, and I'm going to say, let's have two functions, f and g, which are inverse. Okay, two inverse functions. And this means then that f of g of x is equal to x. This is the conclusion that we have from the example 1, and we can now apply it here. Now, where is the derivative in all of this? There is nothing in mathematics which tells you you cannot do this. You can always differentiate the given equation or given equality. You can differentiate it. And let's do it. Basically what happens is we have derivative of a composite function. At the moment I don't care that they are inverse. I have derivative of the composite function. And I have on the right side there is a derivative of x. What this means is we are going to apply the derivative of composite function, which tells us that the left side is going to be f derivative of g of x times g derivative of x is equal to x derivative, which is 1. Okay, so the multiplication between the derivatives of inverse function, where in one of the inverses you use the other, is equal to 1. Now, the last thing that we can do, and this is going to be then similar to your textbook, but this is not something that I'm going to encourage you to do in the future, but let's have the theory about it all, so you are prepared in any situations given, because there may be certain tasks when you can apply it, then why not if you can, is that I want to see what is the derivative of the inverse function. And derivative of the inverse function, which one is inverse? You can pick any of these. I'm going to pick the g function as the inverse. I'm going to say that g is actually f to the power of -1. Why? Because in that case, I just want to get rid of the f to the power of derivative of g of x to be able to say what is the derivative of inverse function. And this is going to lead us to the g derivative of x is equal to 1 over f derivative of g of x. So this is the conclusion. And this is first conclusion we can get from the given equation. Now, another thing that you can do is, well, why wouldn't we divide with g derivative of x? Of course you can. In that case, you're going to get that f derivative of g of x is equal to 1 over g derivative of x. And this is the second form that you can use. Now, why am I saying the first one is the one that if you're going to use it? Because I can rewrite this down using f to the power of -1 instead of g. Well, basically, this is f to the power of -1 derivative. So if you want to differentiate a function that is inverse, this is now its name. This is the f to the power of 1 is actually name of the inverse function now. So you derive the whole thing of x is equal to 1 over f derivative. G of x now is going to be f to the power of -1 of x. And this is the form that you can use in the end. There we go. Now this is the theory. This is the thing you can always use. You can apply it whenever you want and it will work. Of course it will work. And this is the theory. Now let's apply it into a couple of tasks. So the tasks themselves are on page 37 in your textbook. And I'm going to write here down the f to the power of -1 derivative of x is equal to 1 over f derivative f to the power of -1 of x. Now this is the let's say law or the formula or however you want to call it. I told you page 37, and let's start with task 3, subtask 1. So 3, 1, where f of x equals to 1 over 2x minus 3. Now what does this mean for us? There is a couple of ways we can find the derivative of the inverse function. So let's start with f to the power of -1 derivative is of x equals, and I'm going to leave here empty space to fill in later when I find everything I need to find. Now, if I want to use the formula given, if I want to use this here formula, I have to actually find two things. The first thing is the inverse function, and I have to find also the derivative of the f. Let's start with the derivative of f, just so that we have it. So f derivative of x is equal to 1 over 2x minus 3. When we differentiate it, we're going to get 1 over 2 in the end. Applying the basically index law, because minus 3 is a constant. When you derive it becomes 0. 1 over 2x, when you derive it, becomes 1 over 2 and x to the power of 0, which is 1 over 2. So we have found the derivative of function f. Let's find also the inverse function. Now, how to find the inverse function? Y equals to 1 over 2x minus 3. We want to express the x using the y instead of expressing y using the x. So change who is expressed with who. So first thing is y minus 3 is equal plus 3, is 1 over 2x. We multiply it with 2 and we're going to get that x is 2y plus 6. And f to the power of minus 1 of x is then equal to 2x plus 6. Now, one thing is, Professor, your teacher, however you want to call it, you have already told us a couple of times when we want to find the inverse function, there is an extra step where we write it down that f to the power of minus 1 of y equals to 2y plus 6, and then we will write it down using the x. You can always do it. I'm just simplifying things. I have limited memory on my mobile phone and limited upload-download bandwidth, so that's why I'm simplifying things a little bit, if I can. But you can always use this, and I'm not gonna judge you if you don't use it, okay? But we have now found the inverse function. Let's put everything into the formula. This means that 1 over f derivative of 2x plus 6 is equal to 1 over, well, f derivative of anything is 1 over 2, which is then 1 over 2, and is equal to 2. Okay, now were we able to simplify it and maybe do it without the whole this here deal? Well, yes, you could have, but the thing is, you couldn't have done it without this here part. Well, why? Because you need to find the inverse function, and we want to find then the derivative of the inverse function. Well, no one tells you that you cannot differentiate f to the power of minus 1. So let's do it from here and see if we're going to get the same thing. So f to the power of minus 1, the derivative of x is equal to 2. Because 2x plus 6, when you differentiate it, you're going to get just the 2. Did we have the same derivative? Yes, both of them are 2. So both methods are correct. Now what I encourage you to do, I told you that this here whole thing that I talked about earlier is the theory. I have to talk to you about theory. I cannot just give you, oh, here is the formula, do it, or forget about it. No, I want you to become mathematically competent, and which means I'm going to spread things a little bit all the time. I do it all the time, and even here and now. But in solving tasks like these, I would encourage you to go through it using the method of inverse function, finding the inverse function, and then finding its derivative, instead of using the formula and complicate things even more. Now, let's apply this in the subtask 3. Let's apply it there. So subtask 3, f of x equals to 1 over 1 minus x. So this is now given in this here case. How are we going to find the derivative of inverse function? Well, let's find it by finding the inverse function itself, which means that y is equal to 1 over 1 minus x, which then tells us we want to express x using the y, so multiply everything with 1 minus x, which means that 1 minus x times y is equal to 1. divide everything with y, so 1 minus x is 1 over y, which in the end will lead to that x is equal to 1 minus 1 over y. This means that f to the power of minus 1 of x is equal to 1 minus 1 over x. And we found the inverse function. Now, we can find its derivative. Now, what I'm going to do here is rewrite it as 1 minus x to the power of minus 1, because this means that this is going to be then 1 minus x to the power of minus 1 the derivative, and 1 when it's differentiated becomes 0, minus still is here, but minus 1 comes ahead of the x to the power of minus 2. Basically, we applied the index law of derivative. So minus minus 1 becomes plus x to the power of minus 2, or 1 over x squared. And this is the derivative of the inverse function of 1 over 1 minus x. Now here, I didn't talk about the domain, the range, and things like that. This is something added to all of this. This is something that I can ask you sometimes. Unfortunately, I don't know if we are gonna come back to the normal classes like we used to, but if we were, I would talk about also these things with you guys, to add all of this, to talk about things so that we don't forget about the range and the domain. And I would like you guys to think about this stuff, even in these tasks when we're doing them. So I'm not gonna now tell you, oh, find the domain, but domain is basically whole real set except 1, because you cannot have 0 in division or divide with 0. So this is what would be in this case, and in the second case, for the inverse function, the x cannot be equal to 0, and so on. So one last task that I would want to show you to complete the talk about the inverse function is task 4.1, where f of x is x plus 1 over 2x minus 3. Now, instead of going through the formula and using the formula itself, let's find the inverse function. Now, for the inverse function, we have to do actually y equals to x plus 1 over 2x minus 3, multiply with 2x minus 3 because we don't want to have division when we don't have to. So this means that 2x minus 3 is times y equals to x plus 1. 2xy minus 3y is equal to x plus 1. X is on the one side, everything else on the other side, which means that 2xy minus x is equal to 3y plus 1. This is the next step, so that we know. Extract the x, which means that x is multiplied by 2y minus 1, and it is 3y plus 1, divide with 2y minus 1, and x is equal to 3y plus 1 over 2y minus 1, which means that the inverse function is 3x plus 1 over 2x minus 1. Now we have to find its derivative. Now this is the derivative of quotient going to be, basically. So let me go here. So f to the power of minus 1 derivative of x is actually 3x plus 1 over 2x minus 1 derivative, which means that 2x minus 1 is going to be squared, while above we have 3x plus 1 derivative times 2x minus 1 minus 3x plus 1 times 2x minus 1 derivative. In the end, when you solve everything, all of this, you should get the derivative of the inverse function is minus 5 over 2x minus 1 squared. There you go. This is today's lesson. Thank you very much for listening, and see you in the next video.